Hi students and friends, welcome to the channel Learn and Teach by Ayaz. I will continue the video lesson for the topic alloys and their properties. Syllabus learning outcomes are for the 2023-25 version for both CAIE 5070 and IGCSE 0620. The SLOs for this video lesson are: describe the uses of alloys in terms of their physical properties, including stainless steel in cutlery because of its hardness and resistance to rusting. Identify representations of alloys from diagrams of structure. Now let's compare metals and alloys in terms of bonding, forces of attraction, diagrammatic presentation of metallic bonding, arrangement of particles, metal strength, softness, and malleability or ductility. Both metals and alloys have metallic bonding, and force of attraction is simply between metal cations and mobile or delocalized electrons. So it's electrostatic attraction. So I'll write metallic here. Bonding metallic. So force of attraction, electrostatic. Between metal cations and mobile electrons. For diagrammatic presentation of metallic bonding in metals, you have to draw metal cations like this. It's in a sea of mobile electrons. These are the free or mobile electrons. You can even write delocalized electrons. Here we also have free or delocalized electrons. In case of alloys, all these things are same. You can see here, the difference is the presence of big size metal cations in between these small size metal cations. So I will draw big size metal cation like this one. Rest of the diagram will remain same. The metal cations are regularly arranged in layers, but this arrangement is disrupted in alloys. This is because big size metal cations are added to a poor metal in the making of alloys. Regularly arranged. Arrangement disrupted by large sized metal atoms. You can write cations. Talking about strength, alloys are stronger than metals. Stronger than metals. So you will write that metals will be fragile or weak. Fragile or weak. Metals are soft and alloys are hard. Metals are highly malleable and ductile. highly malleable, ductile. Which means when you hit the metal, the atoms will slide or slip over one another. On the other hand, the alloys are less malleable and ductile. Less malleable, ductile. This is because large-sized metal atoms disrupt the regular arrangement of metal atoms, which makes it difficult for the metal atoms to slip or slide when struck. Alloying is used to lower the melting points of metals. Is used to lower the melting points of pure metals. For example, the solder is an alloy of tin and lead. And has a lower melting point. Than its constituent metal. And thus it can be used to join metals. Alloys have higher resistance to corrosion. Pure metals corrode easily, which means they react with water or oxygen. Alloys have a higher resistance to corrosion. For example, copper nickel alloy is used to make coins. Instead of pure copper. Here is a list of carbon steels along with their type and uses. The use are due to special properties of carbon steel. For example, if we have low carbon or mild steam, which contains 0.25% of carbon, the uses are in car bodies and machinery. The special properties which makes this uses is that they're hard, strong, and malleable. Now, high carbon steel, which contains 0.245 to 1.5% carbon, is used in cutting and boring tools, for example, knives, hammers. This is due to the reason that high carbon steel are strong but brittle. More carbon atoms prevent sliding in high carbon steel. Alloy steels like stainless steel, alloy of iron, chromium, nickel, and carbon. They are used in equipments in chemical plants, cutlery, surgical instruments. They are extremely durable. Durable means long life. They do not react. Resistant to rust. They have resistance to rusting. And corrosion, even when heated. Here's a diagrammatic presentation of alloys such as brass. See the diagram on the right hand side. These big black atoms are actually zinc. These are zinc. In between, lots of small sized copper atoms. These all are copper atoms. You can even show metallic bonding in brass like this. This is metallic bonding in alloy. Metallic bonding in alloy or brass. These are zinc and copper atoms along with mobile or delocalized electrons. Again, these are copper atoms. And these are zinc atoms. Here's the past paper question. The answer will be like this. First of all, I'm going to read the question. Explain how the properties of low carbon and high carbon steel differ. Low carbon steel is softer as it is more malleable. Low carbon steel is softer as it is more malleable. High carbon steel contains more carbon atoms. Which prevents sliding of the iron atoms. Hence, high carbon steel is harder but brittle. This is another past paper question. Use the diagrams below to explain why an alloy of iron and manganese is less malleable than pure iron. The diagrams given will help you with answering this question. You see here that in pure iron, the layers can slide when force is applied. This is the layer of iron atoms. So when we apply a force, this layer will slip, which means the shape will change. On the other hand, an alloy, the larger atoms stop the layers from sliding. So this is alloy of iron and manganese. Here, these are large atoms. They prevent the atoms from sliding over one another. So we will write in pure iron, the layers can slide when force applied. And in alloy, the larger Mn atoms stop the layers from sliding. So here's the summary of this video lesson. Both metals and alloys have metallic bonding and electrostatic force of attraction between metal cations and mobile or delocalized electrons. Pure metals are weak and soft. The atoms of the same size are regularly arranged in layers which can slide over each other easily when force is applied. Pure metals are the soft and malleable. In alloys, the regular arrangement of atoms in the pure metal is disrupted by the addition of other atoms of a different size. Therefore, it is difficult for the atoms in an alloy to slide over each other. This makes alloys harder, stronger, and less malleable than pure metals. Alloys have a low melting point and high resistance to corrosion. Low carbon steel is used in the making of car bodies and machinery. This is because low carbon steel is hard, strong, and malleable. High carbon steel is used in the making of cutting and boring tools like hammers, knives, etc. High carbon steel is strong but brittle. Thanks for watching. Press like, give comments, and share my video. For more videos, subscribe my channel and press the bell icon.